Okay, so the design part of first experiment and the second experiment, that is a full adder, half adder, full subtractor, half subtractor, and again the design part of the code converter, that is a binary to gray and gray to binary. So I think you are clear with this, the design concepts, right? So design concept is nothing but to get the expression by just looking into the K-map, and you are writing the K-map by just looking into the truth table. So this procedure we have already followed and we have completed the two experiments. Okay, so that is related to the design part of the first two experiments in the digital part. So coming to the third experiment, so it is related to the MEV technique. Okay, so MEV technique I have already explained in the theory class by taking many examples. Okay, we have solved n number of numericals in order to understand the MEV technique or EVM technique. MEV is nothing but the map entered variable technique. Okay, so the third experiment is completely based on MEV technique. So and again implementation. So how we are going to implement it by making use of this MEV technique is we have to use or we have to implement by making use of the multiplexer. Okay, so therefore I am considering the concept called as a multiplexer in today's video. So why I am explaining the multiplexer is actually the third experiment is related to the MEV technique, but if you want to implement the circuit you have to use the multiplexer IC. So in the first two experiments what you have used only the AND gates, OR gates and NOT gates, right? Only you have used the basic gates. So coming to the third experiment you are supposed to use the multiplexer, and again do not worry, the multiplexer is easily available in one particular chip, that is an IC, integrated circuit. So before using that you should know what is meant by multiplexer, right? You are all the computer science students, so you may be not knowing what is meant by multiplexer. So multiplexer and demultiplexer is nothing but the combinational logic circuit. So it will be used in communication field usually. Okay, usually it will be used in the communication field. Let us not go in depth, but let me just explain how much ever it is required for your lab purpose. So what is a multiplexer? So multiplexer is a combinational logic circuit. Okay, it is a combinational logic circuit used to select only one input among the several inputs based on the selection lines. Okay, so if you just see the diagram of the multiplexer, so there are n number of inputs towards the left side and only a single output towards the right side, and now at the below part there is a selection lines. So what does the definition says? It is a circuit, combination logic circuit used to select only one input among the several inputs. It will be selecting only one particular input among the several inputs based on the selection lines. Okay, so here for example here there are 8 inputs, means it will be selecting only one input, that whatever the user want, and it will be providing the output. So how it will be selecting a particular input? It will be based on the select line. I will just show one example, then you will understand. So I hope you have understood what is the definition of the multiplexer. So it is a logic circuit used to select only one input among the several inputs. Only one among several. Only you will be getting only one output among the several based on the selection line. So no need to pad the definition. You can easily write down the definition by just looking into the diagram of the multiplexer. So now let me write down. So how I have written this diagram? So 2 to the power of n mux. So whatever the mux I have written here is a general diagram of the mux. So 2 to the power of n mux. Okay. So n means the number of inputs that we are. The n is nothing but so d0, d1, d2 till d to the power of n minus 1. How many select lines are there? S1, S2 till Sn. So the number of select lines will be the number of bits that you are considering. So let me consider 2 is it. Let me consider n is equals to 3. Okay. Okay. So if I am considering n is equals to 3, so what the answer will become? Here 2 to the power of 3 is nothing but 8. So 8 cross 1. So you are supposed to design an 8 cross 1. So S1, S2, how many S? What is the value of n I am considering? I am just considering n as equals to 3. So therefore your select line will become S1, S2 and S3. Okay. So now you are starting from D0. So therefore your data inputs will become, let me show that. Okay, D0, D1, D2, D5, D6 and D7. So these are the 8 input lines. Okay, here there is a 8 input lines and here there is a single output line. So now, as the definition says, it will be selecting a single particular input and it will be providing that selected input to the output. Right? So how it will be selecting? So what is the number of combinations that you can write? If the number of bits that we are considering it as 3 bits, it is again 2 to the power of 3, that is 8 combinations. So 0, 0, 0, 0, 0, 1, 0, 1, 0. However you are writing the truth table for the 3-bit representation, the similar way I am writing it 0, 0, 1, 0, 1, similarly 4 zeros, 4 ones, like that. Okay. For example, if your selection line is 0, 0, 0, it will be selecting the D naught and it will be providing the output. It will be selecting the D naught as an input and it will be providing D naught the output. Now if my selection line is 0, 0, 1, okay, if my S1 is equals to 0, if my S2 is equals to 0 and if my S3 is equals to 1, then it will be selecting D1, it will be selecting the D1 among the 8 inputs and it will be providing the output. And if my selection line is 0, 1, 0, that is S1 0 idre, S2 1 idre, S3 0 idre, it will be selecting D2 and it will be providing D2 to the output. So now if I want D7 to be selected and if I want D7 to get to the output, if I want to move my D7 from the input to the output, then what my combination should be? Obviously it should be 1, 1, 1. Okay, I hope you have understood how this 8 cross 1 marks will work, and again I just show how this 4 cross 1 marks will work. Okay, so therefore you will be perfect with the concept of multiplexer. So 4 cross 1 is nothing but 2 to the power of 2 cross 1, right? So how many inputs will be there? There will be 4 inputs. So represented as D0, D1, D2 and D3, and again only single output. How many select lines will be there? Sn, that is S1 and S2. Okay, so now how many combinations that you can write by making use of 2 bits? You can write 4. So that is 0, 0, 0, 1, 1, 0 and number. Okay, so now if my select line is 0, 1, then what input will be selected from this many inputs? It will be selecting D1. Okay, it will be selecting D1 and it will be providing as an output. In case if my select lines is equals to 1, then which input will be selected? It will be selecting D3. It will be selecting D3 and it will be providing as an output. So even though there are n number of inputs, it will be selecting a single input and it will be providing the output. So we can call this multiplexer as a data selector. Remember, we can call this multiplexer as a data selector. Keeping this concept in your mind, please carry this concept whenever I am explaining the MEV technique. Okay, you all know how to write the MEV technique table. Okay, so we have solved the problems. You have to write the 3 variables instead of using the 4 variables. All those problems we have already seen in the previous slides. So keeping the MEV concept and keeping the mux concept in your mind, we should understand the third experiment. Okay, thank you.